Hello, my name is Ken Sosinski, and this is my presentation on sustainability and infrastructure. So the need for infrastructure. The reason humans need infrastructure is the requirement of food, water, and shelter. Now the main thing that I would do as a structural engineer is shelter. Infrastructure, because of the energy requirements needed to create infrastructure, obviously is greenhouse gas emissions. Now greenhouse gas emissions obviously affect the environment, which in the end hurt us as human beings. So it's a hard line to figure out where the correct place to be is. If you take a look, the main way or the main thing that this presentation will be going over is the mitigation of these effects through coordination of the owner, the architect, the structural engineer, which is myself, and the HVAC system supplier. So you can see here the effect of greenhouse gases on the environment. You can see an increase of 2 degrees Celsius in the past 100 years. This blue line shows the human factors affecting the environment, and the green line would be what would happen if we weren't here. The industry emissions, the main thing that causes CO2 emissions is electricity generation, which can relate back to the effectiveness of your building. And then way at the top, you can see residential and commercial structures also play a large role in CO2 emissions, which is what we are trying to mitigate. Here shows the materials that I, as a structural engineer, actually have some say in. You can see that 25% of construction materials of steel, 19% of cement those percentages are related to the total CO2 emissions of construction. This counts for 17% of all CO2 emissions. And the way that I can reduce those emissions directly is to use less material. And I can use less material through the advancement of strength in materials or types of materials, such as steel, high-strength steel, and high-strength concrete. Some other things we can do is use different mixtures in our concrete. As you can see here, adding slag to your typical Portland mixture can reduce your CO2 emissions. So I can talk to a provider of that concrete to see what we can do about using slag cement. Some energy reduction tactics. I will not be able to directly influence these, but I can have some small say. So in residential buildings, you can see that the most needed energy source is heating, and in commercial, it's lights. With heating, that would be mostly up to the architect and HVAC supplier in providing the most effective system. In lights, that would be mostly down to, again, the HVAC system supplier and architectural company. One thing that I can do is not record a presentation at midnight with all the lights on. So here we can see the coordinated design and energy reduction systems with solar collectors, so you can make a black roof that would hopefully take in more heat. Some small scale cooling units, which is just high efficiency units. And software, in this day and age, software can save you a lot of money. Normally when an HVAC supplier does something, they just look at a volume of area and then supply a unit that can cover that area. With software, we can see how they interact with each other and how we can more efficiently have our building heated or cooled. One difficult thing about these high-cost solutions, well, except for software, is telling the owner, hey, so you're going to pay a lot of money up front, but it'll save you in the end, because they're probably going to go, no, it's less of a loan, I'm going to not do that. With coordination in the HVAC system, one thing I've noticed as an engineer, which bugs me to no end, is that they don't get involved until the last 2 weeks of the project, and you have to change the sizes of all your joists and members. One other problem this causes is a low efficiency of HVAC units with the architect, because the architect will be putting insulation in random locations where they might not need it as much if they knew where the cooling or heating units were. One thing that we can change, or one way we can change this, is have the mechanical engineer or HVAC supplier get involved earlier in the process. The reason we talk about this now is because the predicted future is all but grim. You can see in this chart for residential and commercial buildings for the energy usage with respect to time. In the next 50 years, we can expect in residential buildings 180% increase in energy usage. And in commercial, we can expect 184% increase in energy usage. And obviously, unless Tesla comes up with some crazy contraption that can make energy reverse itself, we need to worry about the greenhouse gas emissions that are caused by this increase in energy. Some challenges I have as the engineer of record is the little effect I can actually have on the energy side or the electricity side of the process. I can reduce the material usage, but I can't reduce it much more because I'm already using the least amount I can to match a bid set and have the lowest price possible. I have no real control over the materials used. While I can tell the owner and architect, hey, you can't do wood there, most of the time they know what material they're going to use and they know that it works because they've done it before. So I have to adhere to their will. Another thing is I don't have any real control over the energy effectiveness. That comes down to the architect and that comes down to the HVAC supplier. And one last thing, I have very little effect on the effectiveness or energy emissions of the building. So I can't tell the owner, hey, use low cost or use high efficiency, high cost equipment and try and make your building more energy efficient. In the end, that comes down to the architect, that comes down to the government, that comes down to the owner. As a structural engineer, my expertise comes in using the lowest amount of material possible. And one way that I can help the other aspects or the other personnel, the architect, HVAC supplier, the owner, is to coordinate with them early on and get things settled in stone right away. And with reducing our energy emission through this method, hopefully we have a safer, better future for our children. Thanks.